Hi, and welcome. My name is Adele, and I'll be your host as we learn how to clean data in Python. In this course, we're going to understand how to diagnose different problems in our data and how they can come up during our workflow. We will also understand the side effects of not treating our data correctly and various ways to address different types of dirty data. In this chapter, we're going to discuss the most common data problems you may encounter and how to address them. So let's get started. To understand why we need to clean data, let's remind ourselves of the data science workflow. In a typical data science workflow, we usually access our raw data, explore and process it, develop insights using visualizations or predictive models, and finally report these insights with dashboards or reports. Dirty data can appear because of duplicate values, misspellings, data type parsing errors, and legacy systems. Without making sure that data is properly cleaned in the exploration and processing phase, we will surely compromise the insights and reports subsequently generated. As the old adage says, garbage in, garbage out. When working with data, there are various types that we may encounter along the way. We could be working with text data, integers, decimals, dates, zip codes, and others. Luckily, Python has specific data type objects for various data types that you're probably familiar with by now. This makes it much easier to manipulate these various data types in Python. As such, before preparing to analyze and extract insights from our data, we need to make sure our variables have the correct data types. Otherwise, we risk compromising our analysis. Let's take a look at the following example. Here's the head of a data frame containing revenue generated and quantity of items sold for a sales order. We want to calculate the total revenue generated by all sales orders. As you can see, the revenue column has the $sign on the right-hand side. A close inspection of the data frame column's data types using the .dtypes attribute returns object for the revenue column, which is what pandas uses to store strings. We can also check the data types as well as the number of missing values per column in a data frame by using the .info method. Since the revenue column is a string, summing across all sales order returns one large concatenated string containing each row string. To fix this, we need to first remove the $sign from the string so that pandas is able to convert the strings into numbers without error. We do this with the .str.strip method while specifying the string we want to strip as an argument, which is in this case the $sign. Since our dollar values do not contain decimals, we then convert the revenue column to an integer by using the .astype method, specifying the desired type as argument. Had our revenue values been decimal, we would have converted the revenue column to float. We can make sure that the revenue column is now an integer by using the assert statement, which takes in a condition as input and returns nothing if that condition is met and an error if it is not. For example, here we are testing the equality that 1 plus 1 equals 2. Since it is the case, the assert statement returns nothing. However, when testing the equality that 1 plus 1 equals 3, we receive an assertion error. You can test almost anything you can imagine of by using assert. And we'll see more ways to utilize it as we go along the course. A common type of data seems numeric but actually represents categories with a finite set of possible categories. This is called categorical data. We will look more closely at categorical data in Chapter 2. But let's take a look at this example. Here we have a marriage status column, which is represented by 0 for never married, 1 for married, 2 for separated, and 3 for divorced. However, it will be imported as type integer, which could lead to misleading results when trying to extract some statistical summaries. We can solve this by using the same .astype method seen earlier, but this time specifying the category data type. When applying the describe method again, we see that the summary statistics are much more aligned with that of a categorical variable, discussing the number of observations, number of unique values, most frequent category, instead of mean and standard deviation. Now that you have a solid understanding of data type constraints, let's get to practice.